Hello readers, this is Professor Mario Molina, a scientist who won the Nobel Prize for Chemistry. Now I'm going to use the example of Professor Molina to teach us about connections, or drawing connections between scientific information in a text, in a piece of writing. Because reading scientific papers often involves learning about a bunch of new information all at once, and then learning how all of that new information connects. How is information connected? Before we dive into Dr. Molina's life and research, let's use a simple example. A bowl of noodles, say. Let's put a little sauce on those noodles, maybe a little bit of pesto. Just a little bit of green, a little bit of basil. Here's a basil leaf. So, using this bowl of pasta as an example. In a piece of nonfiction, we can learn why something happened. We can learn why the pasta was made. Maybe I was hungry. We can learn how something happened. So in the case of the pasta, I cooked it in boiling water and then drained it and put some sauce on top and put it in a bowl. We can learn how one event impacted other events. Let's say I had a very late lunch at like 4 p.m. that consisted of this pasta, and then by 7 p.m. when it was time for me to have dinner, I didn't have as much of an appetite because I'd spoiled my appetite with this big old bowl of pasta at 4. And we can also learn how events cause other events. So say I'd had my late lunch of pasta, and I wasn't ready for dinner at 7, so I decided to push dinner back a couple of hours. That's, I'm an adult. I eat when I want. Now, I know this example is a little silly, but I wanted to talk about something relatively simple, like a bowl of noodles, before we dive into Dr. Molina and his research, which is about pretty complicated scientific concepts. So these are just 4 of the ways that information can be connected. These aren't the only 4 ways, these aren't the only ways to think about information, but these are some of them, and this is a helpful way to think about making connections when you're reading. So this is taken from a passage on the website about Mario Molina's research. I'm going to read this passage, and as I do, I'm going to try and find connections between pieces of information in the text. I'm going to try and pull out of the passage the stuff that the author wants me to know, and the stuff that the author wants me to put together. As a professor, Mario Molina tackled a question that no other scientist had before. It was, how do chlorofluorocarbons, what a long word, chlorofluorocarbons, CFCs, affect the atmosphere? Now this is interesting because these are parentheses, and the parentheses are telling us that CFC is a shorter way to refer to chlorofluorocarbon, which I'm going to assume is some kind of chemical. And how do they affect the atmosphere? So what is the impact of these CFCs on the atmosphere? And specifically sentences like these that are built up like this, right? So the passage is setting up the idea that no other scientist had ever asked this question, or hadn't successfully managed to deal with it, tackled it, right? What is the impact of these CFCs on the atmosphere? And if you don't know a word like atmosphere, now is a really good time to look it up, right? The atmosphere is the layer of air and gases that surrounds the rocky part of our planet. So we can just say the air, just sort of as a rough definition. So how do CFCs affect the air? And so now we've been cued to look for some sort of cause-effect relationship. Now we've been cued for some sort of relationship between CFCs and the atmosphere. They affect it somehow. They do something to it. Let's keep reading. CFCs are chemicals, great, once used to cool refrigerators. Okay. So this is starting to answer my next question, like what are CFCs? They were also used in things like hairspray. So hairspray and refrigerators. Now, I don't use a lot of hairspray, but I do have a refrigerator in my home, which leads me to think that CFCs used to be pretty common. That's what these 2 sentences together tell me. I also keyed in on the word once here, which suggests to me that they used to cool refrigerators, and they used to be used in things like hairspray, but I don't think that they are anymore, probably because of Molina's research. At this time, in the 1970s, the public believed that CFCs were safe to use. All right, so now I know when this research is taking place is in the 1970s. This also kind of explains the hairspray thing. If you've ever seen a movie from the 70s, people had a much, much, much bigger hair than they do today. So we know that in the 70s, the public, like everybody, believed that CFCs were safe. However, Molina discovered something else. Something else other than what? Well, because of where this transition is, it's in the next paragraph, and it's kind of reflecting back on the previous sentence, I think we can say that something else is that CFCs were maybe not so safe to use. Something else was true. After release, CFCs rise up into the Earth's atmosphere. There, solar radiation breaks them down into something called chlorine. Chlorine destroys the ozone layer, which shields Earth from the sun's harmful rays. All right, so that's a lot of information all at once, and that's a lot of relationships of information all at once. So we've got our little can of hairspray. There it goes. And after it's used, it rises up into the atmosphere where rays from the sun hit it, and that breaks it down into chlorine. And chlorine destroys the ozone layer, which protects us from the harmful rays of the sun. So let's go back to our pasta bowl, and instead of pasta, scribble that out and replace it with the destruction of the ozone layer in the 70s. So why did it happen? And the answer to that is CFCs got into the atmosphere. I'm just going to write CFCs atmo. How did something happen? Well, when the CFCs get hit by solar radiation, they turn into chlorine, and the chlorine eats the ozone layer. And what is the impact of the ozone layer being destroyed? More exposure to solar radiation. And what caused this to happen? The use of CFCs in hairspray and refrigerators. So when you're trying to make connections in a scientific text, ask yourself these questions. Why did something happen? How did it happen? What are the impacts from that thing happening? And does it cause anything else to happen? Taking the information from a text and then kind of plugging it into these questions or these thoughts is a great way to figure out how information relates to other information within that passage and how it relates to stuff you may already know about. So we say, thank you, Dr. Molina, for saving the ozone layer. You can learn anything. David out.